Hello everybody, my name is Braam Greeff. I'm a Principal System Engineer at the Defence, Security and Mining Cluster at the CSIR. I focus mostly on mining security problems, and I'd like to present to you some of the research that we've done regarding underground electronic capturing and reporting systems for possible implementation in future mines. The scope of my presentation is basically that I'm going to give you an overview of what we've done in the research project, some of the workgroup findings that we've discovered while we were talking to mining stakeholders, as well as discuss some of the solutions in old and new mines that we propose for the future. Now, to give you some context, current safety management processes in mines are currently still implemented as a fairly manual, error-prone practice, often leading to legal non-compliances, instances where mine stoppages occur, which is often very costly to mines. The current manual data safety recording and management practices should hence be reimagined, and this is what this research is all about. If one looks at the key personnel working underground, the shift supervisor, or in the old range shift boss, plays a key role in the recording of safety data on a daily, weekly and monthly basis in mines. So it's vitally important that we enable the shift supervisor of the future to record safety data in underground operations in a more diligent, legally compliant method. And this is what we suppose will enable mines to have less stoppages on an annual basis. We kicked off the research by conducting work sessions with key mining stakeholders, practitioners in the mining safety context, as well as we identified a few mature OEM suppliers that could bring value to the discussions. And what we discovered in our work groups was that there's an overwhelming need for a new way of thinking, a new way of recording data, less manual, more electronic, more in an automated way that will enable the shift supervisor to do a job in a more repetitive, legally compliant way. So there's definitely a need to develop an electronic way of recording safety data on a daily basis. The current legal framework really only makes provision for really manual paper-based processes, which is one of the reasons why mines are still using manual processes. So the other key finding that we discovered was there's older mines and newer mines. What we mean by that is that the older mines still don't have infrastructure relating to information systems, network systems underground. They still are very much on a manual basis, while the newer mines has well-developed, well-deployed ICT infrastructure. So the solution of the future should basically provide outcomes to both of those type of mines that you find. Now, if you look at the paper-based safety logbook that shift supervisors are currently using according to legal requirements, it caters for general information, daily information, monthly and weekly information. Now, our research has found that probably the majority of the paper-based logbooks that you find today in mines do record a lot of process-based requirements or parameters that's not really legally required, and the really legal required safety related data is hidden somewhere in there. So the idea and the suggestion from the work group was that let's review the really legally required safety data that needs to be recorded on a regular basis and only do that in electronic way. All other process-based information should be recorded by any other means. So people are recording too much data that's not really legally required, and then you get audited on that, your mine get closed, and you pay a lot of money for that. So let's clean out house and let's define a new logbook that can be used in future for electronic implementation. Now, looking at the operational view of existing mines, is that it's basically the mining activity is happening at the stope, and there's no communication information flowing from the stope to the surface. Everything happens paper-based, very slow, and your management cycle is also compromised in the sense that you only get the data 24 hours late, and making decisions on delayed data is not always optimum. While your newer mines do have well-established ICT infrastructure, they have mostly fiber-based LAN systems that's already installed with Wi-Fi spots at key areas, which can be used in future for shift supervisors to basically record their data and basically submit it underground, which means that data is in near real time available at the surface to be processed, and the operational manager and shift managers can then use that data in a much more proficient and efficient way. If we look at the possible solution that we suggest for the future is basically a tablet, which is an Android operating system tablet. It can be Apple-based as well, with legally compliant safety data recording software and application that runs there. And then the shift supervisor can take that tablet down to the work area, record the data in a structured way as demanded by the software, and then basically just save it, walk to the closest Wi-Fi spot and just upload it, which then will make it available at the operations rooms at the surface. We are also depicting some of the other elements there on the context diagram. What we do foresee in future is that PPE equipment should contain wearable technology in future, which will enable the shift supervisor to have a hands-free ergonomics to do his job, and then only use the electronics and the tablet when it's required without using too many manual operations with hands and arms. Okay, just to sort of focus a little bit on the future, what we foresee, possible wearable technology. It's already, many of the technologies are already available and can be embedded inside PPE equipment, overalls and so on of the future. So we see the connected miner of the future, which will typically have a communication device, wirelessly linkable up to the ICT infrastructure, a tablet that's a tablet pouch actually that's inside the PPE, and tablet can just be pulled out whenever it's required. Obviously other biometric sensors like temperature sensors, heartbeat sensors, life sensors, a video channel in the helmet, and also an audio channel that the supervisor can use to communicate as well. Obviously the crucial other subsystem is obviously a power supply that will last at least a shift. So we see in future that the shift supervisor of the future arriving at the shift just basically pull on the PPE, wearable technology, and go into the shift, is immediately connected and can do a job to basically record data in an automated way. Way forward, we did develop in our research a requirement set that we can now use to involve further development activities with selected OEMs, where we can now develop a application software package that can be used by mines, installed on tablets, record the information, and then what we should do in future is do a pilot implementation at a test mine site where this can be evaluated, and the management effectiveness that emanates from that can be properly evaluated and quantified. I thank you very much.